Alrighty, so we got down this far talking about population parameters. A parameter narrows down to a certain population. It's kind of your restrictions, your limits that define, hey, what is this population made up of? Okay, we found out yesterday that all the populations have fixed parameters, but parameters are going to be numerical ways of narrowing it down. So we talked about you have to have a certain number of credits to be called a senior. All right. So we were just starting to look at this problem. Suppose average miles per gallon (mpg), which is a number we can measure numerically, for all passenger cars manufactured in the United States in 2013 was 23.6. All right. Then 23.6 is a population parameter. All right. So it's a numerical description of a particular population characteristic. So if we take a blank.
Number?
Okay. Hang on.
Census.
All right. Oh, it is census.
Oh.
All right. So if we take a census, we can have what % confidence about the data that we've gathered from the whole group?
90 something?
It should be 100%, because what's the definition of a census? We talk to every person. So if we can take a census, now, when they take the census in the United States, do you think they actually get everyone? But that's their goal. That's what they're aiming for. All right? They probably have some parameters that they're allowed to go, okay, this is good enough, because, we can't find Fred. Well, we know Fred lives there, but Fred's never home, or something like that. But the goal, officially, the definition of a census is you talk to every single person. If they need a census of the seniors to vote on something, they may get all the seniors and bring them all to the gym at one time to vote on something, or they may have all the seniors in their English class have to fill out a survey or something, but they're expecting it, and then, somebody's absent, they keep chasing that person down until you haven't filled out this form, okay? All right, so that would be a census. All right, so a census is not always practical. I mean, what if there's millions of people, or thousands of people, or thousands of animals, or thousands of cars?
Thousands of stone sculptures.
Thousands of stone sculptures in their population, okay? And you don't have time to gather information from every single one of them. When a census, I don't even know where that came from. When a census cannot be obtained, we gather information from a blank of the population.
Portion.
It means portion.
Ratio?
Okay. Let's
Sample.
sample. You're getting close.
Part.
Let's think from part. So let's think back to what we learned earlier this year when we had an entire set, but
Single
then we
set.
just took a portion of a set,
Subset.
a subset. So if you think of the entire set as being the population, talking to everybody would be a census.
So,
But that's not always practical. So we may look for a portion or a part or a subset.
so is the next one a subset of a set?
You are on the right path. So our next definition is a sample. All right? And it is definitely a subset, not a census,
Population.
of a population. Okay? So census is how many people we interview or talk to. A subset is how many, population is the whole group. All right? So we are going to get some other words. A sample statistic. The blank description of a blank of a sample. Does that kind of look familiar?
Kind
Numerical?
It's a numerical description.
of a fixed of a sample.
Okay. Well, where do we have a sentence that's kind of like that? Okay. A parameter was a numerical description of a particular population characteristic. Okay. So a parameter is a way of putting a number to describe a characteristic of a whole population. A sample statistic is a way to put a number on not the whole population, but just a sample, but we're using the number to describe a characteristic. Characteristic, okay, I got all the right letters there. So, we've got a parameter versus a sample. Y'all, here's the deal, okay? If this is my whole population here, whole population, and then this is just a subset, a part of my population. Actually, this would probably be a better. Here's my whole population. And I get a subset. I don't have time or resources to talk to every single person in the population. I just talk to some of them. We have some vocabularies that go with it. If I want to describe a characteristic of the whole population, what do we call it?
A census.
No, if I want to describe a characteristic.
Characters.
Okay, it's a parameter. All right? A parameter is going to be a numerical description of some characteristic. But when I use the word parameter, I'm talking about the whole population. What if I just look at this little piece of the population and I want to put a number on that same characteristic? It's a sample statistic. So a statistic is when you gather data, right? What's missing there?
Spelled that wrong.
I'm just going to turn that into a T, stuff an I in there, now we got it, right? Okay, so a couple ways to help you remember. Population, parameter. Subset, sample statistic. A subset is just a sample of what we've got, right? It's a smaller amount, and we gathered a statistic. So that might help you remember the differences, because on the vocabulary test, those are very close definitions. They're both talking about putting a number, a numerical description of a characteristic. They both take a characteristic and count it some way. They put a number on it. But one, you just dealt with a small part, a sample, and the other one you've dealt with the entire population. Does that help? Okay, so let's move to the next page. My notes. Get your notes. So what I just drew for you on the board there might help with this. As a matter of fact, do you think I could get that picture here? We've got the whole population. So if I want to, oh, sorry, I'm not even where you can see me. I've got the whole population. If I want to put a numerical characteristic of the whole population, what do I call that? A parameter. But let's say I want to get a smaller portion of the population. What do I call that smaller portion? Yeah, so do we say sample or do we call it a subset? Okay, that's for my subset. And the characteristic, this is also small, I can hardly fit it in here. The characteristic is called a
Sample statistics.
sample statistic. Okay? So, probably should have drawn that picture at the bottom of the page before. I'll try to remember that next period. All right, so let's see if we can take what we know about a population versus just a sample, fill in some blanks.
Whole group.
Whole group, good deal. Well, what do we say about the sample?
Group I want, part of a,
Part of a group. Okay. All right, so the next one's kind of an interesting thing. I don't think I would have thought of these things if I hadn't looked in the book. So this is the group I...
want,
It is. It's the group I want to know about. I am trying to find out information about the entire population, but maybe that population is just too big for me to ask everybody and use a... What am I using if I ask everybody? Okay? A census is just too expensive or too time consuming or too difficult to visit with every single member of the population. Okay? But that's who I want to know about. So instead of talking to everybody, I just talk to a small group, a sample, and I try to use this little bit of information to help me understand the whole thing. Okay? So this is the group that I do know about. This is the group that I have decided was reasonable that I could get information from. I'm just going to look at a sample. Let's say a company is producing, the thing that comes to mind is Tabasco. Have any of y'all ever gone to Avery Island in Louisiana and toured the Tabasco company? Okay, I love going there because at one point in the tour, you're standing behind the plexiglass wall and you're just watching the bottles of Tabasco go down the road. Hundreds and hundreds. It's very calming to me. I love to watch videos of assembly lines in factories. I find that oddly satisfying. So you're watching all of the bottles of Tabasco go. Well, they need to make sure that they are all good. But they're not going to test every single bottle because that would be ridiculous. So as you're watching, every now and then, a little plunger comes and knocks one bottle out of the assembly line and it gets pushed to the side, and then a worker comes over and takes that bottle, okay, not the entire population, but a sample. And they go and they check it to make sure the lids are on right, and they test it to make sure the taste tested or whatever. Make
Those
sure
of you that have completed the Edu Hero, this isn't for you. We have a few that are still needing to complete the online training, so you don't need to come, that last week of May. So we're going to open the window back up one more time. So if you're not done with your Edu Hero, try to do it ASAP. Let me know as soon as you finish them. Thank you.
Feel like that could have been an email. Anyway, okay. So, anyhow, they are just testing this one sample. And if they do every 50th bottle or whatever, they just randomly have that plunger that it just knocks out a bottle every now and then. If all the bottles in the sample seem to be fine, that's when they assume. Yeah, but the rest of them are probably fine as well. Okay? So, would it be really expensive to open every bottle and test it? Well, first of all, if they open the bottles that have been sealed, they no longer can sell that sample bottle, can they? They've broken the seal, so they would just ruin their whole product. So the samples don't go. At our church, we have a peanut butter factory in Houston that makes peanut butter and bottles it, and those bottles of peanut butter are used for welfare donations. So sometimes they're sent to third world countries. Sometimes they are given to families that are, having just financial problems and needs groceries. Sometimes they're sent after a disaster, they ship that in. And so I've worked at the peanut butter factory a few different times, taking my turn there. And at the peanut butter factory, they pull out a sample. You're sitting there watching to make sure all the lids go on, and every now and then this guy walks by and he grabs a bottle of peanut butter. And he goes and he opens it and makes sure that the machine is sealing properly, and then he breaks the seal and he takes out a scoop of peanut butter, and I don't know what he tests it for, consistency, taste, whatever, making sure it's right. Well, then he's got this bottle of peanut butter that they can't sell. But they run that bottle back through the machine, reseal it, put the lid on it, and set it aside. So us workers got to take home sample bottles. But when you open them, there's like a scoop of peanut butter missing. You're like, what? And they said, don't freak out. This was one of the sample bottles. So they didn't open every single bottle. They don't do a census because how would they ever produce anything and sell it, right? So they pull a sample. Does that kind of give you a better idea of what we're talking about here? Okay? So, do I want to know about the whole batch of peanut butter? Yes. But I actually do know about the sample bottles. Okay? All right, the next one. Numerical descriptions of the characteristics in a population are called parameters. The numerical descriptions of the characteristics in our sample are called? Say it again.
Our samples.
It's a sample statistic. Okay? So our sample is not the whole group, it's a subset, right? All right. Now, blank is generally known, blank is always known. I'll give you a hint. The parameters are generally known. Let's go back to our peanut butter factory. They probably know, yeah.
You're saying known. Is it unknown?
You say known instead of unknown. That's what we're getting.
Oh, okay, yeah, all right. Never mind. Let's back that up, okay? So the parameters are generally unknown because we don't sample every single item. Sorry, excuse me. All right, I appreciate y'all. Really appreciate you guys for being my guinea pig group. The parameters are generally not known. Why?
Because they can't, like, they're not doing a census.
It's not, we're not doing the census. It's not convenient or possibly budget-wise, it's not affordable or convenient or possibly even it's not possible to check with every single one. Now, when the United States does a census, they are trying to check with every single household, aren't they? All right? But the peanut butter factory, they're not opening every jar, taking out a scoop and testing it. So they don't really know about everything in the group. But we do know, but we don't use the word parameters here, do we? So, yeah, and they just use the word statistics here. So the statistics, which apparently is a very hard word for me to get on paper while I'm talking, if I don't stop and think. The statistics are known because you gather data from the sample. But you didn't gather data from the entire population or you'd have a census, right? Okay. Now, the parameters are blank and the statistics blank.
Parameters are constant statistics.
Okay, so we had this on the front page and we didn't use the word constant, but it pretty much means that. Fixed, very good. The parameters are fixed. We know the quality we expect from our peanut butter, all right? Or we know how many grade points a senior should have. Okay, those are fixed. That is fixed. All right. In the statistics, we actually now test. Hey, is it what it's supposed to be? So you know what this means if they're not fixed?
Very.
They vary. So depending on what the data we gathered says, maybe we have the parameters we're expecting for the population, and maybe we find that we're not. What if the peanut butter factory finds out that the quality of the peanut butter is not correct? Maybe it's got, too much oil in it or something. They may need to now say, okay, wait, we may have an issue with this batch. They may need to test a whole bunch more, find out if it's just that one jar, find out others. But that'll lead them to make changes or to know what's going on. All right. So, identifying parts of a survey. So, 2 shortened survey reports are given. In each report, I need you to identify the population, the sample, the results, and whether the results represent a sample statistic or a population parameter. Okay, we're going to look at 2 different studies here, 2 survey reports. Somebody did surveys and they gave a report. Now, y'all listen. How do you think we will know if our results represent a sample statistic or a population parameter?
One's part, one's whole.
Okay, so if it's a population parameter, they will take the results of the survey, listen to me, so they take the results of the survey and then they make a general statement about the whole population. So if they say 58%, find out if it's 58% of your sample, or if they're applying it and saying it's 50% of your whole population. Okay? So if your results are just talking about the part of the group, it's a sample statistic. If they're talking about the whole population, then it's a parameter. Okay? So, survey number 1. A headline about the rising obesity among young people led to a school board to survey local high school students. All right? Out of the 231 students surveyed, 58% reported that they were eating a high-fat snack at least 4 times a week. Y'all, I think I'm eating a high-fat snack at least 4 times a day. Yesterday I bought a bag of cookies and I ate like 5 of them in the afternoon, and then I ate like 4 of them before bed. I don't even think I'm waiting for the week. So, school board would be shocked. All right. Think about this. Population versus sample. What's the population here?
Young people.
Okay. What sort of young people?
Obese young people.
Okay, not obese young people. Read that whole sentence. They surveyed who? Okay, so these are not just all high school students in the world, but local high school students. This is a school board, probably with a school district. They're probably only worried about the kids in their town. They're not really worried about the kids 50 miles up the road, okay? So it said they surveyed, so this is the population that they surveyed. But when they're taking a survey, they don't always get results from everybody. They may have sent the survey by email to every kid in the district, but they ended up, when they say a survey, you're talking about a sample, okay? So what's the sample? How many people out of all the local high school students did they?
58%.
Okay, no, back that up. How many students responded? How many people actually?
231.
Okay, so the 58% is a conclusion that they made. They wanted
That would
to.
be a result.
Okay, it's a result. Okay, so what were the results? What do the results say?
58% ate a high-fat snack.
Okay, now the key is 58% of who, because that's going to have us decide if it's a sample statistic or a population parameter. is the 58 just out of the people they surveyed, or are they saying 58% of all the local high school students?
The ones that they surveyed.
Ah, so, all right, so there's, the sample was the 231 students who were surveyed. So does that mean there were only 231 high school students in that district? Okay, so they just surveyed some of them. All right, and we'll talk in the coming days about how do you get an accurate survey. Y'all, if they just stood outside of the gym after a basketball game, outside of the locker room doors and surveyed those kids, do you think that would be a good sample?
If you're trying to like get a sample of just
Of-
sports players.
But I want a sample of local high school students.
Yeah.
So I need to try better. I don't want to just get, do I just sit at the Dairy Queen in town and wait and see what high school students come by? They're all getting high fat right there, right? Do I go ask the kids that run track in the afternoons for, no. So you need a better sample. We don't know what kind of sample. We're hoping they got maybe a random sample, but we'll talk about how do you get good samples as time goes by, okay? So the results are 58% of who?
Of the sample.
Okay, 58% because it says out of the 231 students. So 58% of the 231 students surveyed. All right, and what did the 58% do?
They said that they eat high fat snack at least 4 times a week.
Okay, eat high fat, and was it at least 4 times a week? So what does at least mean?
Greater than or equal to.
Greater than or equal to 4 times a week. Was that a sample statistic or a population parameter?
Sample statistic.
Okay. Let's look at the next example. A nonprofit organization interviewed 618 adult shoppers at malls across Louisiana about their views on obesity in youth. The resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation of high-fat fast food options. So we need the population, the sample, the results, and is it a population parameter or a statistic? We've got all sorts of stuff happening there. What piece of that do you think you can see?
The population is Louisiana adults.
Ah, okay. The population in our results, we're talking about all of the Louisiana adults. So, did they interview? Are there only 618 adults in Louisiana? So they didn't. Would it be practical for this nonprofit organization to interview every adult in Louisiana? But their parameters were, we're talking to the adults, right? So our population was Louisiana adults. What was the sample?
618 shoppers.
But they're adults, right? Now, when we try to decide, are they giving me a sample statistic or they're giving me a population parameter, we have to look at the results. Do the results just tell me how many of the 618 people did something, or do they apply it to the whole population?
By whole population.
Okay, so let's see, Hayden, what were the results?
48% out of 618
But it's not out of
Wait.
just the shoppers.
are in favor.
Okay, they're in favor, but it's 48 out of
Louisiana
all, so they're applying their statistic to the whole group here. So 48% of adult, let me see, Louisiana adults. Let's abbreviate Louisiana with LA adults. Okay, and they were what? In favor, how can we shorten what it is? They're in favor of what?
Fast food regulation?
Okay, we'll go with fast food regulation. All right. Now, this is not saying 48% of the shoppers surveyed. They have applied it to the whole Louisiana adult population. So it is a population parameter because the results were applied to the whole population.
Uh-oh.
Oh, yeah.
More notes.
All right. So, talking about choosing a sample. If you're going to take a survey, you're going to have to be careful how you choose your sample. And, y'all, they've been putting questions, I think they even put questions on like the 7th and 8th grade STAR test to decide, to help students decide which one of these is a good sample of a population. And then they may say, let's see. The ASPCA, the American Society for the Prevention of Cruelty to Animals, is concerned about what we've been concerned about. You know, how well dogs are taken care of in the winter or something. I don't know. All right, and so then they give you. So they surveyed, you know, cat owners. Well, that's not a good sample. Okay, they surveyed all the people in the pet store, or they surveyed every 5th shopper coming out of Walmart. Well, that's kind of two different things. If you're surveying the people who are going to go spend money in a pet store, those are probably people taking real good care of their pets, right? Okay. If they survey just the people in one neighborhood, that's probably not a good survey of all the pet owners in the area. So anyway, you have to come up with a representative sample. So for a representative sample, let's see what we can come up with for some words. Carson, you with me? Good? Okay. All right. So a sample that has the same blank characteristics as the population, I bet you're not going to guess the first one, and does not blank one group of the population over the other. I bet you have a bigger chance of getting the second blank.
Same parameters?
Same numerical.
Okay?
Numerical?
You would think so. Relevant. Okay, so what does that word mean? Something is relevant. What does that mean?
It's important in this context.
It's important in this context. It applies to this group, okay? So if I want to get a representative sample, I want to get a sample that has the same important characteristics as the whole population, all right? So I don't want to just survey, if my population is Deweyville High School seniors, and I want to ask and try to get an idea of what sort of college plans they have. If I only ask the honor grads, is that a group that has the same relevant characteristics as the whole group? All right. Well, by the way, if I need to get information from Deweyville High School seniors, I might as well just take a census. There's not that many of them. Yeah. How big is y'all's graduating class?
Like 38.
38? Yeah, I think I would do a census to that.
Okay, so there's like 46 of those.
Okay. So, all right. But if I wanted to find out about seniors across the state of Texas. It may not be as easy to do a census for that group. So if I want to get a sample, do I only talk to students in Houston? Okay, so we need to get a sample or a subset that is somehow going to match and represent the whole population. Okay, and it does not blank one group of the population over another.
Prefer?
Very close. I mean, your meaning is almost identical. It's favor. But you definitely could have said prefer there. Okay? So we don't want to favor one population over another. All right. So here are some ways to get representative samples. And it's called a representative because it represents the group well, even though you didn't ask an entire census. Okay? So a random sample. A sample in which every member of the population has a blank chance of being selected. Okay. So randomness means you have access to the whole group, but you only send the survey out to certain ones, but it's random. Y'all, look at me. Humans are not great at random. You may feel like you're doing something random, but you know, if I tell you to list random numbers, do you remember that? Remember when we were doing the coin flipping, and I had y'all try to fake me out on you actually did the trial and flipped the coin, what was it, like 200 times?
Yeah.
Or something, and you're writing heads, but I had two spaces, and in one of them you were actually flipping the coin, and in the other one you were just making up heads and tails. And then I said I thought I could guess, and for every one of your groups, I was able to guess in this class, right? Okay, so do you know what I was looking for? Do you remember what I was looking for to?
Good groups are the same.
Yeah. When something is truly random, you should expect the unexpected. So if it's truly random, you should maybe get heads 5 times in a row. But when somebody's trying to generate random, they tend to not do that. Heads, tails, heads, tails, heads, heads, tails, tails, heads, tails, you know. And so I was able to guess y'all's by seeing how often you repeated.
I don't know
Because in
how
the
you
real-
guessed
Actually-
it when we just flipped
Actually,
it. I don't
both of our
understand.
classes, or both of our groups in here didn't do
I was
that.
gonna
We
say,
just used the
we just-
previous table and did something to it.
Okay, I think some of y'all, was it y'all? Okay, maybe it's the
Yeah,
other class.
it was-
But in one class, they
Yeah, it was
did
us.
the actual table,
And we flipped it.
and then they turned it backwards. They
Yeah.
copied it in
I think that was
reverse,
our group.
and it threw me off.
Yeah, and then
Okay.
we did it from bottom to top. We copied it back.
Okay, so it was still the exact same data
Yeah.
in the exact same sequences, but just flipped. Okay, so note to self for next year, you can't do that. So I think
You told third period. That's
Yeah.
how it did.
right. So isn't that third period managed to come up with some other thing that was, I can't remember. They did something else, but I think in the future, I will say, don't show me, but I want you to make up yours first. Okay, and then I want you to do an experiment, but I don't care which one you put where. So you try it, outdo it. But on the people I was able to guess, it was because they just never really had any longer sequences. Because when you're trying to create random, humans don't create random well. They just don't. So this says it is hard for blank to choose members of the population in a completely random manner. Humans. They just don't randomize well. So for that reason, it's best to take the blank element out of choosing and allow blank to choose the random sample.
Human and computers.
I got technology, but you got the same idea. Take the human element out of choosing and allow technology to choose a random sample. So years ago, bless your little heart, before you sneeze, I probably ruined your sneeze by
Yeah.
blessing you before you sneeze. Now you're just stuck with the sneeze inside your head. Okay, years ago I taught at Brook City Junior High, and and they were giving out incentives for perfect attendance. I think it was, something. They're trying to inspire kids to have perfect attendance, and they had some prizes they were giving out for people that had perfect attendance. I think at that time there was like this 2-week window that the state did a snapshot of attendance, and that's how they decided what your attendance was, and all the money that the school gets is determined by the attendance, the average daily attendance. And so during that attendance week, they would do all sorts of incentives to try to get kids to be at school, and if you had perfect attendance so far, your name would go into a drawing. Well, the math department guy had, he had figured out that the TI, back that time, this was like TI 73s, but they had a random number generator program in them. So every day they would print out a list of all the kids with perfect attendance for the day, and they numbered them. Well, he could set the parameters, if there were
Is that still a
75
thing
kids.
For like these calculators?
Yeah, and I don't even remember where it was. It probably still does, because those calculators morphed into these calculators. But that was seriously 30 years ago. But he would use the calculators to randomly generate the numbers. He would use the technologies, because people can't randomly generate, because they're gonna choose a low number one day and a high number the next day, and they're gonna try to balance while they're randomly choosing. Random doesn't try to balance. So technology can truly grab something at random. Humans have a hard time doing that.
Yeah, on the calculator,
Uh-huh.
press math, go over to
Yeah.
prob, and
I don't
there's
know.
like 5 different random
Probabilities, and there's some ways to generate random
Yeah.
things. Good, kind of cool.
5 out of the 8 functions there are randomness.
Okay, cool.
Wow, you did just enter it just.
Yeah.
Yeah.
All right, so, show me that, because I don't have it on my head.
Click math, go over to probability.
Okay, math, okay, math, probability, random, integer.
Yeah.
And so if I go from 1 to 100, and N is probably counting by ones, because I
Yeah,
can count by
probably.
decimals like 0.5 or whatever. And it just randomly generated 95. If I go up, grab it again, it generated 91. If I was doing that, I would have chosen 95 and 91 as my first
Yeah.
one. And then it's at 15. Thank you. I'm glad. Oops, stop the video.